with an outer diameter of 40 mm and inner diameter of 37 mm. We are required to calculate the absolute maximum shear stress developed in this pipe. When we look at the image on the right section, we see this pipe is experiencing different torque values. So, in order to determine the maximum shear stress developed in this pipe, first we need to determine the maximum applied torque. To do that, we have to cut sections along the pipe. One right here, between 80 Newton and 20 Newton. And then the other one is going to be here. And the next one right there. So we need 3 different cuts. Let's look at the first cut. If I cut my section right at the end, I have 80 Newton meter at the end of the pipe, and this 80 Newton meter is contracted with torque value of 80 Newton meter. So if I have 80 Newton meter going clockwise, then I have to have a opposite torque value acting counterclockwise with 80 Newton meter. So when I have my second cut, I have 80 Newton meter at the end, 20 Newton meter following, and then if I sum these up, this is going to be negative because I assume that clockwise is positive. Then I'm going to be left with 60 Newton meter. Next, if I have my last cut all the way at the end, I have 80 Newton meter going positive direction on clockwise, and I have 20 Newton meter that's going counterclockwise, negative, and I have plus 30 Newton meter because it's clockwise, which leaves us with 90 Newton meter torque. Next, we're going to look at our equations. We have only one equation to calculate the maximum shear, and we already determined the maximum torque, and I mentioned this in the previous class. C is the distance from the neutral axis to the point where we want to measure the shear stress, but in this case, since we are looking at the maximum shear stress, we have to look at the outer diameter 40 millimeters because that's the maximum distance from the neutral axis. So torque value was 9 Newton meter. C is the radius, so 40 divided by 2 is 20 millimeters. And we're gonna keep the units in meter. And then polar moment of inertia, pi over 2. The outer diameter minus inner diameter divided by 2. So this is the radius, and this is outer radius, this is inner radius. So if you calculate this, you will get 26.7 megapascal.